All right, good morning. So, I told you that I was making a video for today's class, and so here I am with my video. So what we're doing today is we are looking at the homework, and then we're going to move into the actual lesson, which is about cube roots, okay, cubes and cube roots, okay. So first of all, I want to go over the homework from last night, so I'm just going to go ahead and write the answers for 4 through 18 even up on the board, and then we'll kind of talk through 21 through 25 all, and 28 and 29 before jumping into the lesson. Okay, so we have, this is 21 centimeters, right? This is because area is the same as saying the side squared. So if my area is 441, I say that is equal to side squared. So the square root of 441 is equal to 21 centimeters. Okay. So then over here for my circle, my area of a circle is pi r squared. Okay. So again, I plug in 64 pi for my area, pi r squared here, divide by pi on both sides to get 64 and r squared by themselves, and then I take the square root of both to get r is equal to 8 inches. Okay, so that's how we do those. Okay, so for 8, plus our two answers, as we should know, is plus minus 8, and then 10 is plus minus 12. Okay, then we have 11 as plus, or 12 plus minus 14. 14 should be negative 3 over 10, right? We should know that because we just take the square root of 9 over the square root of 100, and that gives us 3 over 10. And we can't simplify that anymore, so we just have negative 3 over 10. Okay, so then 16 I have, right, we talked about moving the decimal over twice, so this is actually the square root of 729. I know that the numbers are getting a little bit big, but if we did the work, we would know that the square root of 729 is 27. Then we move the decimal place back once. All right, so the answer here is 2.7. Okay, and then 18, we have negative 2.25. So we, again, do move the decimal place over twice, so we have 225. Okay, the square root of that is 15. Okay, then move it back once, so we have the answer is negative 1.5. Okay, so looking back at 21 through 25 for homework last night, we talked about yesterday when we have expressions that we first need to do what's under the radical first, and then we can start simplifying from there. Okay, so we have the square root of 9 squared plus 5. So we should have the square root of 9. What we're saying is the square root of 9 times the square root of 9, okay, which is just equal to 9. And then we add in the rest of this. So plus 5 is equal to 14. Okay, similar here. We have that same kind of idea. So 28 minus 144, right? Because our squared and our square root sign cancel out, so that makes a negative 116. Okay, 22, we have 3 times the square root of 16 is 4, minus 5, so this is actually 12 minus 5, which is 7. Okay, and then we have 10 minus 4 times the square root of 1, which is 1, over the square root of 16, which is 4. Okay, so this simplifies to 10 minus 1, which is equal to 9. Okay, so we omitted 26 and 27. All right, and so now our numbers are starting to get really big. So if we're looking at this, we have 676, right? The square root of 676. So you have the square root of 676, which is equal to 26, right? If we do the prime factorization that we talked about 2 days ago, this will give us 26, okay? And so we move back that decimal place to make this, that the square root of 6.76 is actually 2.6 plus 5.4, which is equal to 8, okay? Then we have the square root of 8, or 8 times the square root of 8.41 plus 1.8, okay? So when we do this, the square root of 841, right, is going to be 29, right? And I know that we didn't exactly cover this, but so when we move it back, it's going to be 8 times 2.9 plus 1.8, or 1.8, okay? And so this is going to be 23.2 plus 1.8, which is simplified to 25, okay? So let's kind of talk through 28 and 29. So it says the area of the base of a square notepad is 2.25 square inches. We need to know what the length of one side of the base of the notepad is. This is similar to what we did in 4, where we had the square. Okay, we talked about the square notepad. So we have the area is equal to 2.25. All right, so we want to know square inches. So we want to know what the length of one side is. So we say that 2.25 is equal to side squared. Okay, when we take the square root of that, we should know by now, after doing all of this practice, that the square root of 225 is 15. So one side is equal to 1.5 inches. Okay. And then lastly, we have 29. So there are 2 square roots of 25. Why is there only one answer for the radius of the button? So really, the answer here is just that we can't have a negative measurement for the radius of a button, right? So we can have a positive, right? So we know that our 2 square roots here are 5 and negative 5, right, for the radius of the button. So we should know that we cannot have a negative measurement. Okay? And so this is how we did the homework from last night. Okay? So if there are any questions, make sure to jot them down so that I can answer them on Monday when I return. Okay? All right. So if there are no questions, if you didn't write anything down, you can go ahead and put this away. You should have completed the tic-tac-toe for the do now. So that should be done, as well as now the homework. So as you should know, in the regular routine of things, we are now moving into the notes for the day. Okay, so I'm going to go ahead and switch over to the next page. Okay, and so we're talking about finding square roots. Okay, so if we're reading this together, the sub should have given you the notes for today. If not, please go ahead and pause the video at this time to make sure that you have these correct notes that I have up here. Okay, so at this point, we're going to go ahead and start. So yesterday and the day before, we started talking about square roots and their squares and their square roots. Today we are starting to talk about cubing numbers and their cube roots. So similar to the square of a number, the cube of a whole number is called a perfect cube. Okay? We talked about yesterday there being perfect squares, so today we're talking about perfect cubes. Okay? And so some examples of some perfect cubes are going to be things like 8, 27, for example, 64, and we can go on and on with those. Okay. So the opposite of cubing a number is called the cube root. Okay. And so a cube root of a number is a number that when multiplied by itself, right, and then multiplied by itself again, okay, it equals the given number. Okay. So similar to what we talked about before, the cube root with the radical sign symbol is still called the radical sign, and the number inside is called the radicand, okay? So, for example, we have 7 cubed is the same as saying 7 times 7 times 7, which if we do the math, 7 times 7 is 49, okay? And so 49 times 7 is going to be 7 times 9 is 63, okay? 7 times 4 is 28, plus 6 is going to be 334. So our answer here is 343, okay? So the cube root of 343 is equal to 7. Okay, so next we need to go ahead and find each cube root. And I want to go ahead and encourage you to go ahead and make sure that you're doing this on your own first. See if you can figure it out. If not, I'm going to keep going. But if you're going to try it on your own, go ahead and pause it for a few seconds. Try them on your own. And then go ahead and check your answers when we are done here. Okay, so for number 1, the cube root of 8 is going to be 2 times 2 times 2, which is equal to 8. Okay, so then we look at the cube root of 125. So I know that 5 only goes into 5, right? There's no other numbers that go into 5, so I know that this is going to be a factor of 5. Okay, so 125, or a multiple of 5, I'm sorry. So 125, the cube root of 125, I know is going to be 5, and so then 125 divided by 5 is going to be 2. 10 is 25, and then 5 times 5, or 5 times 25 is equal to 125. Okay, so I still need to break this up, because remember, for a cube root we need the same number multiplied by itself 3 times. Okay, so as I know, the square root of 25, right, is going to be 5. So 5 times 5 times 5, I know then is equal to 125. Okay, moving on to number 3, we have the cube root of 1 over 64. As we talked about before, when we take a cube root of a number, it's going to be the same thing as taking a square root of a fraction, or the cube root of a fraction is going to be the same thing as taking a square root of a fraction. So take the cube root of 1 and the cube root of 64. Okay, so I have 1 over 64, which will be the cube root of 64 is going to be 4. Okay, so our answer here is 1 over 4. Then 27, the cube root of 27 is going to be 3, right? Because 3 times 3 is 9, and then 9 times 3 is 27. Okay? So sometimes when we take square roots or cube roots, there will be a negative sign on the inside. And so for an example, we have the cube root of negative 27. Okay? So when we have a cube root of 27, of negative 27, this is allowed. I know that when we talked about square roots, it's not allowed. There's no solution for it. But when we take the square root of a cube, or the cube root of a negative number, this is allowed. And so how does this work? Well, I know that that 3 cubed is going to be 3 times 3 times 3, which is equal to 27. So when I take the negative 3 cubed, right? Negative 3 cubed, that's going to be negative 3 times negative 3, which I know is going to be positive 9, right? And negative times negative is positive. So negative times 3 times negative 3 times negative 3 is going to be positive 9. Then I multiply that by negative 3 one more time, and that gives me the negative 27 here, okay? Therefore, the cube root of negative 27 is going to be negative 3, okay? And so that's how we do that, okay? And so just some practice examples. And so again, I'm going to encourage you to go ahead and pause for a second just to try them on your own, see if you can figure them out, and then we will, I'm going to continue on to go through how to do these and what the answers are and stuff like that. So you can go ahead and pause that now. If not, I'm going to keep going, okay? So the cube root of 1, I should just know that anything times, or 1 times 1 is 1, times 1 is just going to be it's just going to be 1, okay? And so then the cube root of negative 512, so we talked about, I think the closest we got was 125, so the cube root of 125 was 5. So maybe just have to go a little bit bigger. So 6 times 6 I know is 36, times 6 is going to be 216, I believe, okay? Still need to go higher, all right? So let's see, 9 times 9 is 81, okay? Times 9 is going to be 729. Oh, look, I found my cube root of my next practice example. Okay, so the cube root of 729 is going to be 9, okay? So then too high, so it must be in the middle there, so I'm going to try 8. So 8 times 8 is equal to 64, times 8 is going to be 512, okay? So my answer here, because it's negative, is going to be negative 8, right? Because we talked, just like we just talked about, negative 8 times negative 8 is positive 64, times another negative 8 is going to be negative 512, okay? We found what 7 is. Let's look at number 8. So number 8, we have the cube root of negative 125 over 343, okay? So the cube root, again, same thing like we did with square roots. So we take our individual cube roots in our fraction. So we already said that the cube root of 125 is 5, sorry. And then we also said that the cube root of 343 at the top of the page is going to be 7. So this answer here is going to be negative 5 over 7. Now, I don't want you to go ahead and sit there and think that you're confused and that you're alone and that you can't do this, because you can do this. It's just this chapter, as I've stated in the past, is difficult because there's a lot of memorization to it, right? We're not using the calculators, okay? This is a disservice to you if you're using a calculator right now. We're not using a calculator, so, because you're not going to get it on the quiz. Okay, you're not going to get it on part of the test as well. Okay, so this should be starting to come into memory. Okay, so if we flip to the next page, we talk a little bit about prime factorization. So prime factorization, as we talked about a couple days ago, can be used to find the square roots of numbers, but they can also be found to find cube roots of numbers that we don't know. Okay, so again, prime factorization is finding the numbers that when multiplied together make the original number. So what numbers go into 300? So if we go ahead and find that, so 300 I know is going to be 10 and 30. 5 and 2 make up 10. 6 and 5 make up 30. And 3 and 2 make up 6. So these are my, this is my prime factorization tree. Okay, now obviously this is not a perfect cube or a perfect square, right? There's no triples or pairs or anything like that. So, or there is the pair of 2, but there's not multiple pairs that I can go ahead and break off to make a square root. So I can use this prime factorization to find the cube roots of numbers I don't know or remember. So how do I do that? So I need to determine the cube root of 1,000, okay? So what I can do, I can use prime factorization to go ahead and find the numbers that make this number up. So 1,000, I know that that's going to be 10 and 100, okay? So when I break up 10, it's going to be 5 and 2, just like we talked about just now. 100, I know it's going to be made up by 10 and 10, again, 5 and 2, and then 5 and 2. Okay, so there's my factorization tree. Okay, so now that I've broken 1,000 into the smallest possible numbers that make it up, I want to look for triples, okay, of the same number, and group and multiply them together. Okay, we're going to group and multiply them together. So what am I going to do here? I'm going to go ahead and circle in a different color, changing colors now, my triple. So I have 5, 2, 3, it's my triple. And then I have 2 as my second triple. So, and I actually made a boo-boo when I wrote this. This should actually only be 2 because there's only 2 triples here. Okay, so, and I'm going to take one number from each triple and I'm going to multiply them together to get the cube root here. So I have my triple of 5. Okay, so 5 goes there. I have my triple of, let me actually erase that and give it the right color. So I have 5 times the cube root, or 2 from my triple there. Okay, and that's going to give me my answer of 10. Okay, so therefore the cube root of 1,000 is 10. Okay, so I want to go ahead and give you the chance to do this on your own. So you can go ahead and pause the video at this time, and then I'm going to continue on. So please go ahead and try those on your own, and then come back and you can do them with me and see how you did. So, all right, so 1331, it's a little bit harder because only certain numbers go into some of these numbers, okay, like 1331 or 1,331. Okay, so I know just from the example that I just did that the cube root of 1,000 is 10. So what I want to do is I'm going to try and go up one more. So I'm going to try 11. 11 divided by 1331 is going to be 1. It's going to give me 23, sorry. It's going to give me 22. It's going to be 11, so 1. So 121. I know that 121 is made up by 11 and 11. Okay, so I have my triple here. So my triple is going to make this as 11. My cube root of 1331 is 11. Okay, let's try another one. So 1728, I know that the cube root of 1331 is 11. So let's try one more up, okay? So 1728 is a little bit easier because it does end in the 8, which is a multiple of 2. So I'm going to try 2. So I have 2. 1728 divided by 2 is 864, and you can go ahead and check my math on that. Here, I'll do it with you here. So 1728. Okay. So 2 divided by 17 is going to be 2 is 16 is 12 is 6. Oh, I'm sorry. It's 8. Sorry. 8 makes 16. 12 and 6 is 0, and 8 is 4. Okay? So 864 is the quotient between 2 and 1728. So then I'm going to do 2 again, and 2 divided by 864 is 432, which then is 2 and 216, then is 2 and 108, then it's 2 and 54, then 2 and 27. We know that 9 and 3 make up 27, and so 9 is made up by 3 and 3. Okay, so I'm going to go ahead and change colors here. So I have a pair here, a triple here at 2, another triple here at 2, and then my last triple at 3 here at the bottom. Okay, so again, I'm going to take a number from this triple, I'm going to take a number from that triple, and a number from this triple. So 2 times 2 times 3 is going to be equal to 12. So my cube root of 1728 is 12. Okay, So now let's bring it down a little bit. We're going to go a little bit easier. So 512. Again, I'm going to do 2 and 256, then 2 and 128, then 2 and 64, which is then 8 and 8 actually. And so I know that 4 and 2 make up 8 for both, and then 2 and 2 and 2 and 2 here. Okay, so again, I look at my triples. I have a triple there. I have a triple here and a triple here. Okay, so 2 times 2 times 2, or 2 cubed, as we've been talking about, is 8. Okay, so my cube root of 512 is 8. Okay, 2197. Now we're talking big boy numbers. Okay, so 2197, not the easiest thing. I'm just gonna go ahead and give it to you. 13 and 169. Okay, so 169 we should know by now that is only made up by 13. So again, my triple, and so my answer here is 13. Okay. So this is all the notes for today. Okay, this was all cube roots and cubes. Okay, as we know that cubes are the opposite of cube roots and vice versa. Okay, so this is what we're doing. Okay, so on Monday, we'll go ahead and we'll talk about evaluating expressions that have cube roots, similar to what we did yesterday with square roots. Okay, and so I will also go ahead and take questions on anything that we need to do, but I want to go ahead and make sure that we're remembering exactly what to do, exactly how to do this. So at this time, when the video ends, you can go ahead and take out your flippables that we started on, what is it, I guess, Wednesday at this point. Okay, so take that out, finish that up. Okay, do, I think it's 1 through 20 to find the cube root there. Okay, and then just continue to study. Okay, continue to memorize what these are. Okay, I know it's a lot between square roots and cube roots. Okay, but we have our quiz next week on, I want to say it's Wednesday. Okay, on this. Okay, which I know is the half day. But I would rather get this done ahead of the Thanksgiving break so that this doesn't pop out of our head as it likes to do, even just over a two-day weekend. Okay, and this time we'll have a 4-day weekend. Okay, so go ahead and take out those flippables, finish those up, and then once you finish those, we have practice sheets for you as well. So I wanted to go ahead and say thanks for listening to the video. Thanks for following through. If you have any questions, again, please write them down. I'll be open to answering any questions that you may have on Monday. All right, and I hope that you have a fantastic weekend. I will see you bright and early on Monday. All right, have a great day.